In the annals of statistical innovation, the year 1949 marks a significant milestone, with the publication of Harold Hotelling's A Generalized Multivariate Analysis. His seminal work, emerging from a period of rapid advancement in statistical methodology, offered a profound reorientation of how researchers approached complex datasets. It provided both a theoretical framework and practical tools for analyzing multiple variables simultaneously, a critical shift away from the then dominant paradigm of univariate analysis. Hotelling's contribution was far from a mere technical refinement. It represented the articulation of a new vision, an elegant synthesis of mathematical rigor and practical applicability that continues to shape the modern landscape of statistical science. Prior to the emergence of Hotelling's work, the statistical community grappled with the limitations of univariate approaches when confronted with data involving multiple, interconnected variables. Researchers often resorted to analyzing each variable in isolation or, at most, examining pairs to determine correlations. This approach, while mathematically tractable, often obscured the intricate relationships present within complex datasets. The burgeoning fields of social sciences, economics, and psychology, in particular, were generating data that screened for more sophisticated analytical techniques. These disciplines sought to understand phenomena that were inherently multivariate, where the interplay of several factors determined outcomes. The groundwork for Hotelling's breakthrough was laid by earlier developments in linear algebra, specifically in the study of matrices and eigenvalues. These mathematical tools provided the foundation for understanding the structure of high-dimensional data spaces. Further key influences emerged from the field of factor analysis, developed extensively in the early 20th century, although even these earlier methodologies often lacked a rigorous, unified theoretical underpinning. Hottelling, with his deep grounding in mathematics and statistical theory, recognized the potential to unify these strands into a coherent and powerful analytical framework. A generalized multivariate analysis proposed a set of tools and concepts that revolutionized the field. The central concept was the generalization of the t-squared statistic, a measure of the distance of a set of observations from a known mean. Hotelling's formulation provided a method to test a hypothesis about the mean of a vector of random variables. It provided a way to quantitatively assess the overall difference between groups, taking into account the correlations between variables. The work also extended the concepts of regression analysis to the multivariate setting. Hotelling addressed the problem of multiple regression, where a dependent variable is predicted from several independent variables. He introduced the idea of canonical correlation analysis, a method to find the relationships between two sets of variables. This enabled researchers to explore the correlations between two groups of variables, identifying the underlying dimensions of their association. The mathematical sophistication of Hotelling's approach demanded a significant adjustment in the intellectual toolkit of the statistical community. The core of his analysis involved the manipulation of matrices, the calculation of eigenvalues and eigenvectors, and the understanding of probability distributions in higher dimensions. This was not a simplification but a sophisticated framework, demanding a deeper understanding of mathematical principles. The immediate impact of a generalized multivariate analysis was felt across many disciplines. In psychology, researchers gained new means to study personality traits, cognitive abilities, and the relationships between them. In economics, economists could model the dynamics of financial markets, examining the relationships between prices, quantities, and other factors. In the field of biology, the understanding of multivariate data, such as the measurements of various body parts, provided a means to test hypotheses regarding evolution and species comparison. Moreover, the practical utility of the new methods fueled the development of the first computers. As the computational power increased, researchers had greater capabilities to conduct the complex calculations necessary to analyze multivariate data in a meaningful amount of time. This was especially important as the amount of data available for analysis grew exponentially. These applications demonstrated that statistical analysis could be improved and applied across a wide range of disciplines. The influence of Hotelling's work has echoed through decades. The techniques he formulated have been adapted and refined, becoming cornerstones of applied statistics. The t-squared statistic, for example, remains a widely used test in hypothesis testing and statistical inference. Canonical correlation analysis offers researchers a valuable tool for exploring relationships between complex variables. These innovations inspired later developments in statistical methods. His work provided a framework which was the foundation of many future statistical approaches. Furthermore, as computational power increased, the methods he presented became more accessible. The theoretical and practical value of his work continues to attract researchers. The reception of a generalized multivariate analysis was generally favorable, Although its mathematical complexity proved a challenge for some, the work's theoretical rigor was acknowledged by some reviewers, acknowledging its utility as a foundation for future innovation. The work's impact was undeniable, ushering in an era of increased methodological sophistication in statistical analysis. The initial challenges in wider adoption soon gave way to a growing acceptance. As the importance of multivariate techniques became increasingly clear, graduate programs and research institutions expanded their curricula to include the methods Hotelling pioneered. The impact of his work was to establish multivariate analysis as an essential part of a statistical toolkit. The genesis of Hotelling's work owed a debt to the broader intellectual currents of the time. Carl Pearson's early work in correlation and regression laid the foundation for dealing with multiple variables. Statistical methods introduced by R. Fisher, especially the concept of analysis of variance, indirectly informed Hotelling's expansion. The methods pioneered by Hotelling were a direct response to the demands of applied research, and many other researchers expanded on his discoveries. For example, the work of S. Wilkes and C. R. Mao, among others, further refined and extended Hotelling's techniques. These individuals, working independently, contributed significantly. Their work further solidified the contributions of Hotelling. Hotelling's work exerted a significant influence on many subsequent statistical developments. The methods of multivariate analysis transformed the way data was approached in several fields. His formulations, for instance, played a crucial role in fields such as econometrics, where researchers sought to model the complex relationships between economic variables. The theory of factor analysis, inspired by Hotelling's work, has transformed the field of educational testing and psychometrics. Furthermore, the methods developed for multivariate analysis have influenced the field of computer science. The tools developed by Hotelling were adapted for use in areas such as machine learning and pattern recognition. The legacy of a generalized multivariate analysis resonates in the continued evolution of statistical methods. In conclusion, Harold Hotelling's A Generalized Multivariate Analysis of 1949 stands as a pivotal work in its field. It transformed the landscape, providing a rigorous and versatile toolkit for analyzing multiple variables simultaneously. It offered a paradigm shift in statistical thinking. The concepts and techniques he introduced, rooted in mathematics and driven by the demands of applied research, continue to shape the world of statistics. His work's impact goes further than the technical details, representing a vision for a new future in scientific investigation. The enduring legacy of Hotelling's work is a testament to the power of rigorous theory. It reveals the impact of innovation on scientific progress,